Dear students, in my today's class, we will discuss about the elementary operation of a matrix here. There are 6 operations on a matrix, 3 of which are due to rows and 3 due to columns, which are known as elementary operations or transformation here. Let's start one by one here. I'll give the explanation with the suitable examples. So the first elementary operation is the interchange of any two rows or two columns here. The interchange of any two rows or two columns. So to explain this, I'll consider one example. So A is equal to 2, 3, minus 5, 3, 0, 1, 1, minus 2, 3. The first elementary operations defines interchange of any two rows or two columns. Either you have to apply the row operation or you have to apply the column operation. Okay. So row operation, I'll consider the row. There are 3 rows here. We call this as the row 1, first row, and this is the second row R2, and this is the third row R3. If you are considering the column operation, then this is the first column C1, this is the second column C2, and this is the third column C3. Okay. So first is interchange the rows. So interchanging rows. I'll write the elementary operation as apply R2, row R2. This is the symbol for interchange R3 on A. Apply R2 interchange with R3 on A. That means you have to interchange the row 2 and row 3 of the given matrix A. Then the resultant A dash. Resultant A, so not A dash, resultant A is 2, 3, minus 5. First row is as it is, and second and third rows are interchanged. 1, minus 2, 3. I'll write the third row first. Then the second row elements are 3, 0, 1. So this is the first elementary operation, interchange rows or columns here. Okay. Next, for the same matrix A, I'll apply, either you have to use the column operation or row operation, C1 interchange with C2. Apply C1 interchange with C. You know that this is C1, C2, C3. Therefore, in that case, the resultant of the matrix A is interchange these two columns. Interchange these two columns. So the first entry is 3, 0, minus 2, 2, 3, 1. Write the third column as it is. Minus 5, 1, 3. So these are the elementary row operation and elementary column operation. So this is the first elementary operation. So the elementary operation that defines the interchange of any two rows or two columns. That is, interchange of ith and jth rows is denoted by Ri interchange with Rj. So in this in my example, R2 is interchanged with R3. Interchange the ith and jth column is denoted by Ci interchange with Cj. So in my example, C1 and C2 are yet interchanged. Okay. The next elementary operation is the multiplication of the elements of any row or column by a non-zero number. The multiplication of the elements of any row or any column. So if you take any row, that is a row operation. If you take any column, that is the column operation here. I'll take the same example. So matrix A is this one. Multiply a non-zero element to any row or any column here. Okay, that means you have to multiply each entry of that row or column by that constant. Okay, so here A is the matrix. I'll apply the elementary operation on A like in this way. I have to change the second row of this matrix A. Therefore, changes should be in the second row. What is the changes? Changes should be in the second row. What is the changes? I have to multiply the second row by 2. The number 2. Therefore, I'll write 2 into R2. I have to change the second row. So the resultant should be in the second row. What is the changes? The second row is multiplied by 2. Therefore, the resultant A is, first row is as it is. What are the entries of first row? 2, 3, minus 5, right, as it is. 2, 3, minus 5. Then multiply each entry of the row by the constant 2. That is 3 into 2 is 6. 0 into 2 is 1. Then 1 into 2 is 0 into 2 is 0. 1 into 2 is 2. Okay. Third row as it is. What is the third row? 1 minus 2, 3. 1 minus 2, 3. Okay. For the same matrix, once again I'll write the matrix A here. So matrix A we are considering 2, 3, minus 5, 3, 0, 1, 1, minus 2, 3. Okay. If we apply the column operation, I'll write C1, changes should be in C1. What is the changes? Multiply by C1. So changes multiply by C1 column wise. So the resultant A is the first column will get changed. The entries of first column will get changed. What is the changes? You have to multiply each entry of the column 1 by 3. So 2 into 3, 6. 3 into 3, 9. 1 into 3, 3. Then the remaining 2 columns write as it is. So this is the second elementary operation, that is the multiplication of the elements of any row or column by a non-zero number. That is the multiplication of the each element of ith row by k is denoted by Ri gives k times Ri. Similarly, with respect to column is denoted by Ci gives k times Ci. And the third elementary operation is the addition to the elements of any row or column. I'll consider here only row here. The addition to the elements of any row, the corresponding elements of any other row multiplied by any non-zero number. The addition to the elements of any row, the corresponding elements of any other row multiplied by a non-zero number. The meaning for this is changes in any one row. So I'll consider the changes should be in the first row. What is the changes? Changes is that I have to multiply 2 to the second row and add it to the first row. Okay, addition of the two rows. In that case, one row is multiplied by a constant, or either, or you can write like this: r1 gives r1 minus 2 times r2. That means this is nothing but plus of minus 2, scalar multiplication by minus 2. This is not actually scalar multiplication. Scalar multiplication means you have to multiply each entry of the matrix by a scalar, but here you are multiplying this scalar to each entry of row 2. Okay. So in the previous example, or I'll take one more example here. I'll take the matrix A as minus 3, 5, 0, 2, 1, minus 1, 3, 0, 3. So this is the matrix. So I'll apply this one. Apply R1, changes R1 plus 2 times R2. Okay. Changes should be in R1. What is the first entry? Resultant A. Second column row and third rows are same. There is no changes in these two, only changes in the first row. So what are the changes? The first entry, this should be replaced by this one. Our calculation is R1 plus 2 times R2. Okay, what is the R1 entry? R1 entry is minus 3 plus 2 times, what is the R2 entry? Second row, the entry of the second row is 2. Minus 3 plus 4, answer is 1. Therefore, the resultant entry changes in R1, so that entry is 1. Okay. Then go to the second entry. You have to change this one. Instead of 5, you have to write some other number here. Let's check what is the number. Again, same formula. R1 plus 2 times R2. R1, the entry in the R1 is 5 plus 2 times entries in the R2, the corresponding entry is 1. So 5 plus 2, therefore equal to 7. So this entry is 7. Next, same calculation, R1 plus 2 times R2. Okay, these are rough calculations here. What is the R1 entry? R1 entry is 0 plus 2 times corresponding R2 entry is minus 1. So the answer is minus 2. So this is the resultant A. If you apply the elementary operation, R1 gives R1 plus 2 times R2 on this matrix A. The resultant matrix A is this one. Okay. Likewise, you can apply to the column also. So in general, we write that Ri, changes in Ri, what is the changes? Ri plus k times Rj, and Ci gives Ci plus k times Cj here. And one more thing, you cannot write like this. You cannot write the elementary operations as R1 gives R1 plus 2. This is not the elementary operation. Elementary operation means along with you have to write any one of the row, either R1, either R2 or R3. Okay. So don't write like this. This is wrong. You should write R1 gives R1 plus 2 times R2, or R1 gives R1 plus 2 times R3, like that. Don't write simply a constant here. This is not a elementary operation.